So in these videos, we're going to talk a little bit about the reasons for the seasons. In other words, why do the seasons happen on Earth? In part one, we're going to talk about the basics of solar angle and solar radiation and the importance, how the fact that the Earth is round plays a role in Earth's climate. And then in part two, we're going to combine that with Earth's tilt to talk about how the seasons happen. So let's first take a look at the fact the Earth is round and how that influences the climates that we see on Earth. So to understand this discussion, it's helpful to understand the difference between latitude and longitude. Latitude are these lines running east to west. I'm going to indicate them with this red marker. And I'll circle or put a box around latitude in red to indicate that that's latitude. Latitude lines run east to west, but they indicate north or south. So for example, the 60-degree north line runs east to west, but it tells you you're 60 degrees north. Longitude, which I'll indicate in blue, run from north to south. They're also known as meridians. And they indicate the east, how far you are east or west on the map. So the lines run north to south, but they indicate how far you are east or west on the globe. Now, take just a moment and think to yourself, is the equator a line of latitude or a line of longitude? You may want to pause the video. So the equator is actually a line of latitude. The equator is this line right around the middle of the Earth, and it is at 0 degrees latitude. Now, why is that important? Well, to understand the relationship between the sun and the sun's angle and climate, we have to understand that climate changes by latitude because of the sun's angle due to the curvature of the Earth. So let's explore another concept, the angle of the sun, and how that influences how much energy per unit area we're getting. So here we have an imaginary sun in the sky, and we have two different sunbeams right here. Now with those sunbeams, if I extend this sunbeam down this way, where the sun is directly overhead, I'm down around point A, that I cover only about 1 centimeter worth of space. However, if I do the same thing with this sunbeam, extend it all the way out, we can see that the area around point B that's covered by the sunlight is much larger. So I'll label this a large area, and this one right here, a small area. Now, why is that important? Because these are getting the same amount of sunlight. Same amount of solar energy. However, this one is covering a small area and it's more concentrated. And this one's covering a large area and it's less concentrated. That means that there's more energy per unit area at point B than there is at point A. We'll just have less energy per unit area. Now when that energy hits the surface, it is absorbed by the surface of the Earth, and that light energy is transformed into heat energy. That's how the sun heats the Earth. We'll talk about it more in astronomy, but heat from the sun cannot travel through space because heat itself cannot travel through space. Only form of energy that can be transmitted through space, through a vacuum, is electromagnetic energy, such as visible light. So what happens is that the light from the sun travels through space, gets absorbed by surfaces in the Earth, and that causes them to heat up. Now because at this area here where the sun is directly overhead, it's more concentrated, and here in B where it's at an angle, it's less concentrated. Which one do you think will heat up faster, A or B? I'll give you a moment to pause the video to answer the question. Think about it for a second. It turns out because the energy is more concentrated at A will heat up faster than B will. Now, that's the angle of the sun. And we kind of have a sense for this because we see this every day. We see that when the sun is high in the sky at noon, it's at its hottest. But when it's low in the sky towards the afternoon or early morning, it's actually quite cool. So the sun being as directly overhead as it possibly can be helps the sun heat up the surface of the Earth more. But how does that relate back to climate? Well, if you look at your next page of your helpful outline for these videos, we can see a few polka dots of red and blue got through the sheets, but we can see a nice round Earth in the sun's rays. So an important point here is that the sun's rays arrive parallel to each other as they approach Earth. That is because the sun is so far away. Actually, this was something that was used by the ancient Greeks to figure out that the sun was so far away. They noticed that shadows from your hand from the sun are the same size if your hand is very close to the surface or if it's really raised up high from the surface. The size of the shadow of your hand doesn't change. But if you do that with, for example, a lamp or a torch and a sconce like they would have. They didn't have overhead lights. But if you use it as an overhead light, as your hand gets closer to the light, your shadow gets bigger. So because the sun's so far away, those light rays arrive parallel. So let's take a look at where it strikes different locations of Earth. So here we have the two poles. North Pole and South Pole. And these are at 90 degrees latitude. Here we have the equator, which is at 0 degrees latitude. At the equator, we can see that the sun is directly overhead. But if we imagine a surface, for example, right here, imagine a flat surface here, hitting straight on it. But if we imagine drawing these flat surfaces all the way around the edge of the Earth, we can see all the way up here, which is approximately, we'd say maybe about 70 degrees north latitude, and 70 degrees down here south latitude. We can see here that the sun is striking at an angle. I'm going to vastly exaggerate this. We can see that if we laid a board flat on the Earth, it would be at that angle, and the sun is striking here. It even makes more sense if we draw a little man there. So down is relative to the center of the earth. If we draw a little man on the equator, he'd be facing this way, his head pointed up and his feet pointed down. And we can see the sun would be directly over his head. But over here at 70 degrees north, the sun isn't directly overhead. The sun is much closer to the horizon. And if we draw him at the North Pole, we can see from his perspective the sun is straight out. In other words, the sun is laying right at the horizon. Now the horizon is, if you look straight out and that flat edge of land right where the sun rises at our latitude, that's the horizon, and the sun just stays there even at noon on the equinox at 90 degrees north latitude. So this should give you a basic overview of the important points related to the curve of the earth, the angle of the sun, and how angle influences heat.